Okay, Unit 9.5, we are going to find the vertices.
You could literally throw me.
Vertices. Yes, it's the plural of vertex.
Yeah,
Okay, this shape will have vertices instead of just one vertex. So find the vertices of an ellipse. And sketch. So we have now learned parabolas, pretty in depth. Okay, we've gone over circles. We are now going to work on ellipses. Ellipses are ovals, basically. Okay, they look like ovals or extended circles. Okay, potatoes, if you will, whatever you'd like to call it. So the general form of an ellipse is x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. Okay? Somewhat similar to a circle, somewhat not. Okay? Both have a positive in between. Both have two squares. The differences are this will always be equal to 1. Okay? Whereas in a circle, you have to have everything on the right side. You want your bigger number to be on the right side. In an ellipse, it is always going to be equal to 1 before we do our work, or before we can find any parts. The center comes from, anyone think they might know? Where do you think the center is going to come from? H and K, exactly. It comes from the parentheses. Center is H, comma, K. Okay, exact same thing as we did with circles. You are going to change the signs. Okay, so your instructions are going to tell you to identify the center, vertices, and sketch. So identify the center, the vertices, and sketch. For example number 1, if you are given the equation x minus 2 quantity squared over 9 plus y plus 4 quantity squared over 25 equals 1. Equals 1. So, first things first, let's find our center. What would be the center of this ellipse? Change, so positive 2, negative 4. So, this one, I'm actually going to start sketching first. Okay, so we're going to find all the parts, but I'm going to sketch as I find each part. So we're going to move over 2, down 4. That is my center. Please, please, please label it. Okay, that is my center. Yes?
What is the point of having the division bar?
You're going to see in just a second. Okay. Next thing that we're going to look at is something called the x radius. Okay, the x radius, and remember, a radius is the distance from the center to the edge. The x-axis radius, the x radius, comes from the square root of the x denominator. X radius comes from the square root of the x denominator. So that means, what is the x radius of this ellipse? 3. So that means on the x-axis, which is side to side, you are going to move from your center 3 spaces in each direction and put a dot. So 3 spaces, 1 right there, 1 right here, put your dot. Okay. The next part is the y radius. The y radius comes from, anybody think they know? Square root of the y denominator. Exactly. Okay, y radius comes from the square root of the y denominator. Okay, so this one, what is your y radius going to be? 5. So that means you move from the center, not from 0, 0, but from the center you move up 5, put a dot, down 5, put a dot. Then these are your guidelines to make your ellipse. So we're going to connect the dots. These are going to be, this is what an ellipse looks like. Kind of like, it's supposed to look like an oval. Some people call it like an egg shape. Potato. You guys like potato? It's okay. Now, what you need to know is the smaller radius, okay? In this case, it's the x. The smaller radius, and it's smaller because it's farther, or it's not as far apart. That is what's called the minimum axis, excuse me. Okay, so smaller radius, or, well, technically it's the smaller radius slash diameter, is the, what did I just say?
Minimum.
Not major, minor axis, I'm sorry. Did I say minimum? I'm sorry. Minor axis. The larger radius, or diameter, it's really the same thing if we add them together. The ends of that, or excuse me, the larger diameter or radius is called the major axis. Okay? The ends of the major axis are your vertices. So, your vertices are not always on the x-axis. They're not always on the y-axis. They're at the ones that are farthest away from the center. Okay? So your vertices, one of them is here. What's this vertice? If you label this vertex.
2.
This vertex is at 2, 1. What is this vertex at? 2 should be -9. Okay? That is how you can tell which are going to be the vertices. Vertices just means more than one vertex. Okay? Just like if you had a parabola, it only has one endpoint. This actually looks like it has like 4 endpoints, but it really doesn't, okay? The ends of the major axis are your vertices. Questions on how I did that? Yes?
Is there any way we are able to find the vertices without having graph?
There might be, but I'm not going to show you that. You could do it in your head, that's fine, but I would prefer that you graph. Well, these ones, it's asking you to sketch. On the ones that it doesn't ask you to sketch, if you can reason it out in your head to be which one is going to be larger and figure that out, that's fine. I would encourage you, though, to draw a picture because it's just easier.
There's no, or you won't show us the equation for it?
There is no equation. If you want to like make one up, you can, but there's not necessarily an equation.
Okay.
No, there's not like a formula or anything. Yeah.
Do you want us to write the ordered pair for the vertices?
Yes, because it says identify center, identify vertices, and sketch. So identifying them means write them or label them. Okay, label is fine. Okay, try another one for number 2. I want you to try 9x squared plus 25y squared equals 225. 9x squared plus 25y squared equals 225. What's my problem here? What does this have to be equal to before I can start sketching? And I'm still doing identify center, vertices, and sketch. Has to be equal to 1. So, what do I have to do to get it equal to 1? Divide by 225. Okay, divide all the parts by 225. Luckily, whatever you're dividing by is always going to reduce nicely, just so you know. Okay, so this reduces to give you x squared over 25 plus y squared over 9 equals 1. If you had the same denominator, would this still be an ellipse?
No, it'd be a circle.
No, it'd be a circle. Because if you had the same denominator, that means you'd have the same radius all the way around. If you have the same radius all the way around, that's a circle. Okay, that is a circle. So just keep that in mind. Okay? For this next one, so what is the center of this ellipse?
0, 0.
Center will be at 0, 0. If it helps, you can put this in as x plus 0 quantity squared and y plus 0 quantity squared, but it's not necessary. Okay? How long? So let's go ahead and draw this. So this center will be at 0, 0. Okay? How far out am I going to move for my x radius? 5. So move left and right 5. Okay, so left 5, right 5. How far up and down do I move for my y radius? 3. Too many colors. Therefore, which is actually my major axis here?
X.
The x. What is the length of my major axis? 10. Okay? If you think about it, this is actually 5 away. This is 5 away. This one's 3. This one's 3. So if I asked you, which I'm not on this question, but if I asked you what is the length of your major axis, you add those two together, and it'd be 10. Okay? So where are my vertices?
5, 0,
Right. They're along the x-axis. So if you label these, which I would like you to, this is at negative 5, 0, and positive 5, 0. Okay? You could see these written as plus or minus 5, 0. Okay? That is one way to write it. You can't always do that because, like here, they were two different numbers. Okay? But if it's going to be one positive, one negative of the exact same number, you could write it that way. Okay? It doesn't happen very often, but technically you could. So that's 5, 0 and negative 5, 0. Anyone have questions so far? So this really isn't too bad, but it's kind of combining some of the stuff we did in parabolas with vertices, or with vertex. It's combining some of the stuff we did with circles and, you know, giving you a whole new dimension of other things. Let's try x plus 1 over 2 quantity squared. Notice that this is different than the way I wrote the fractions in number 1, in example 1. This is different. Y minus 3 over 6 quantity squared equals 1. How is this different than what I wrote in example 1? The square also includes the bottom, right? Is there a standard way that it has to be written? No. Okay, sometimes the square will include everything. Sometimes it will just include the top. So when you do this one, what is the center going to be?
negative 1, 3.
This changes nothing about the center. So negative 1, 3. Nothing changes on the center. But what does change is your sketch. Okay, so negative 1 up 3. That's your center. How far do I move on my x-axis? 2. Because if you simplified this, this is the same thing as x plus 1 quantity squared over 4 if you actually simplified it. So x plus 1 over 4 plus...
Yeah, this plus.
Yes.
Okay.
Thanks. Plus y minus 3 quantity squared over 36. Sam. Okay? So, do you have to do that? No. But if you want to follow that it's the square root, you could do that. Or you could just realize that this squared is its own square root. Okay? So, how we're moving on the x-axis is 2. So, you're going to move over 2, left 2, right 2. How far are you moving up and down? 6. So, 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. I promise that on your test, you will be given like nice grid lines. So you're not going to have, you know, goofy looking things like mine. You will have nice grid lines to follow. Okay, so which are your vertices? Where are your vertices? They're at the ends of the major axis. Technically, what's the length of the major axis here? 12, because this is 6, this is 6, this is 2, this is 2. So the length here would be 12. And if I label these points, this should be negative 1, 9, and that's one vertice. The other vertice is negative 1, negative 3. Okay, those are your two vertices. Questions? Yes. Yes. Okay, next thing I want you to do is to put or rewrite the following. Put the following. We're only going to do one of these, into standard form. Now, we say that this is called standard form. Really, it's just more of like graphable form. Okay, so change this so that if I asked you to sketch, you could. It would be easier. So for example number 4, I'm going to give you the equation 4x squared plus 16y squared minus 8x minus 96y plus 84 equals 0. This is exactly why when we did circles and changing these forms, I told you you can't always just divide by that first coefficient, okay? Because here, the coefficients on the x squared and the y squared are different. So that's why I told you I want you to factor them separately. So before you do anything, I want you to do the same thing we did with circles. Put the x's together and put the y's together. X's together, put y's together, and also move the number to the other side. Yes, you will want to leave a space because we are going to do complete the square. Move number to other side. So if we rearrange, we're going to get 4x squared minus 8x, leave your space, plus 16y squared minus 96y equals negative 84. Now I want you to factor out the coefficients on the x squared. So take out a 4. Left behind is x squared minus 2x. Leave your space still. Factor out a what for the y's? 16. Whatever is attached to the squares. So factor out a 16. Left behind is y squared minus 6y. Still leave your space. Equals negative 84. Now, when you complete the square here, okay, we do have to complete the square. Don't forget you're going to have to add it to the right side. Same thing for the y's. You will also have to add that. When you complete the square, we got negative 2 divided by 2, middle number divided by 2 and square it. Same thing. What am I adding for the x's? Plus 1. What do you think I add on the other side? Plus 4, exactly. Since I took this 4 out and did not, okay, I repeat, did not divide it away, you have to multiply it back through, so add 4. If you divided everything by 84, it wouldn't work, okay? It wouldn't work out, so that's why for these, we have to multiply back by that front number, okay? We can't do that yet. You can't make it 1 on this side because you're automatically going to be adding things and then it's not 1 again. So it creates ugly fractions. So that's why we cannot do that first. Whereas in circles, we can divide things away and we don't have to worry about distributing back again. This one, you're going to do negative 6 divided by 2, quantity squared. So negative 3 squared means we're going to add 9. So what am I actually adding to the right side? 144. Okay. Then rewrite these. This is going to give you 4 times x minus 1 quantity squared. If you forget how to get that number, look, it's right here. Okay, that's the exact same thing. Plus 16 times y minus 3 squared, again, comes straight from that middle number divided by 2, equals negative 84 plus 4 plus 144 should give you 64. If you get a negative number on the right side, you made a mistake, okay? If you still can't figure out where your mistake was, let me know because I might have made a typo somewhere. Okay, I'm trying to minimize those, but every once in a while there's a mistake. Now what should I do? What do you think? Divide away the 64, right. So divide everything through by 64, because remember, before I can graph, I do want this to be equal to 1. And these are all nice, reducible numbers with 64. Whereas if I would have used 84 at the beginning, they wouldn't be nice numbers. Okay, you would get totally ugly things. It's not a good situation. So that reduces to be x minus 1 squared over 16. Technically, there's a 1 on the top. I don't have to write that, though. Okay, plus y minus 3 squared over 4 equals 1. From here, this is a lot nicer. It's prettier. And so we can find my center. What's the center of this ellipse? 1, 3. Make sure you're remembering to change your signs. And sketch. Over 1, up 3. Center's at 1, 3. How far should I be moving on the x-axis? So side to side. You're going to move out 4. So left and right 4. How far should I move on the y-axis? So up and down. 2. Up 2. Down 2. Finally, you want to connect those with an ellipse. Make it as elliptical shaped as possible. Mine looks a little unbalanced, but sorry, I apparently made my lines a little too far apart. I'm sorry. Okay, but do your best and then label your vertices. So the vertices here would be what? 5, 3 and -3, 3. Those are your two vertices. Anybody have questions on how I did that? I do still have 4 more examples, but they're just going to be the classifying ones, or identifying the equation. Ready? Okay, last thing. Again, I would like you to identify the following. Identify the following as a parabola, circle, or ellipse. I took away the other category here. Okay, and I'm actually going to write all of these down, and then we'll go through so we can kind of compare them. Okay, for number 5, if I give you the equation x plus 2 quantity squared plus y minus 4 quantity squared equals 1, x plus 2 quantity squared over 25 plus y minus 4 quantity squared over 9 equals 1, 3x squared plus 3y squared equals 27, and 3x squared plus y equals 27. So some of these look similar, but they're not exactly the same. Very small, minor details here. So, what do we think number 5 is? We have 2 squares equal to 1. If it's equal to 1, does it have to be an ellipse? No, because it has the same denominator and or coefficient. So it is a what? That's the circle, right? Okay. How about different denominators equal to 1? Ellipse. Okay, ellipse. Same denominator equal to 27. Circle. Okay. Same denominator, both plus both squares, so equals a circle. Okay. Same denominator, same coefficient, there should be a 3 there. Same coefficient equals to 27, plus in between, 1 square is a what? That is a parabola. That is a parabola. Okay, so this is where it's not that it should be difficult, but where it's starting to get a little bit more difficult because we're just adding shapes. So you have to know and understand the really small differences between a circle and a parabola and an ellipse. Okay, circles and ellipses are probably the closest related and the easiest to get confused on. Questions? Oh, and homework is worksheet 5, numbers 1 through 21. Worksheet 5, number 1 through 21. All. Yes, ma'am. Your test will actually be after